In our teacher time for today, we're going to be reviewing some congruency. Specifically today, we're going to be looking at using congruency to determine the relationship between corresponding sides or angles. So this was something that we briefly touched on, that we saw questions on the benchmark that we ran into, and we failed miserably at them. So we're going to try and step up our game a little bit today, talk more specifically about some of this stuff. All right, first thing I want to look at says let's talk about angles. I think one thing that some of us fail with on angles is knowing exactly what we're talking about when we're labeling angles. There are a couple of different ways you can write every angle. In specific here, it says the vertex must be in the middle. So when we name this angle, the first name I'm going to give it is angle CAB. And you'll notice that my vertex A is in the middle. There's another way I can write this angle or name this angle while keeping that vertex in the middle. What is it, Sarah? Yeah, angle BAC. So, quickly, on the right angle below, go ahead and name that angle for me two different ways. And I'll give you a hint. That's the right angle. Put the little square in there. Adriana, what'd you write? Angle GDH and angle HDG. So what she did is she made sure that she kept this vertex, that point that was in the middle of the angle, she kept that in the center both ways she named the angle. One thing that we really ran into when we were looking at a couple of the questions on the test is they would give us this information about these two shapes, and all they would give us was something like this. They would say triangle KMN, and a lot of us freaked out and we're like, oh gosh, I don't really know what to do here. Triangle KMN. Well, it doesn't really tell us anything about the triangle, so we can draw whatever type of looking triangle we want as long as it's a triangle, and we just put the points on it. And we label it as K, M, N. Easy, right? Draw me a quadrilateral, QRST. See some people drawing rectangles, some people drawing parallelogram looking things, some people drawing crazy looking quadrilaterals. It doesn't really matter, because it doesn't really tell us anything about this shape except for the points are Q, R, S, and T. So you can draw something as weird looking as this, because that has four sides. Q, R, S, T. You can draw something as weird as that. Doesn't really matter. It just needs to have the four sides that and the four angles that you can label as Q, R, S, and T. All right, moving on to the more important concept of today, congruency. We should remember congruency means what? How do we know two shapes are congruent?
That they are the same.
So I hear Kendrick saying that they're the same. More specifically, there were two things we said, Madeline. Yep, same size and same shape. Now, most of us had no problems with noticing things like that when it came to the test. When we talk about same size, that means that the segments are the same, or the sides. And when we're talking about the same shape, that meant that it had the same angles. corresponding angles of congruent, change this to shapes. Corresponding angles of congruent shapes are, and I ask you to fill in the blank here. So let's talk about what it means for things to be corresponding sides. We're going to come down and look at this example. It says congruent, write congruency statements for all the angles and sides for two congruent triangles, A, B, C, and D, E, F. First thing I'm going to do is I'm going to draw those triangles. So it doesn't really, again, matter how I draw those triangles. What needs to be true about this second triangle, though, as I get ready to draw it? Kendrick? Sorry, Kenneth. Yeah, it has to be the same size and shape because they are congruent. So when I go ahead and label them, after I get it drawn, one thing I also have to take into consideration is the way that this is set up. So notice that this is triangle ABC and triangle DEF. I labeled my leftmost point A, my top point B, and my bottom point C. I need to follow the same pattern of labeling if it tells me these are congruent. So I'm going to start with D on my leftmost side, E is my topmost, and F as my bottom corner. To leave myself a lot of space to label that. So with that in mind, this will help us think about what corresponding sides and corresponding angles are. So this angle should be the same as which other angle? This angle should be the same as which other angle? Fernando? It's not how we name angles, but over here where the vertex is, D, those should be the same. Those are corresponding angles. Okay? So corresponding angles of congruent shapes are also, what's the relationship between those corresponding angles? They're what? They're the same. So we would say that they're congruent. Corresponding sides of congruent, once again, shapes. Corresponding sides of congruent shapes are also, fill in the blank, congruent. So same thing here. This side corresponds to this side. And because those shapes are the same size, that means those sides are also the same, congruent. And this is a really important concept geometrically. You'll learn a lot more about how you're going to use this in geometry when you take it in whatever grade level you decide to take it in. For now, we're going to talk about being able to draw those congruency ideas. So how can I write a congruency statement for these two shapes? How can I write a relationship between some of the angles of these shapes? In fact, we've already kind of talked about it. What relationship can I draw between some of the angles in this shape and some of the angles in this shape? Rebecca. Angle A. Remember when we name angles, we have to name them by their 3 points. So she's telling me angle A. How would we realistically name that in geometry, Rebecca? Yeah, angle BAC. Angle BAC is congruent to what other angle? EDF. Notice I'm using the congruency symbol. It's a equal sign with a squiggly line on top of it. So that tells me that those two angles are congruent. What other angles can I draw congruency statements about between these two shapes? Adriana. One more time.
DAB is congruent to FDE. DAB.
I mean.
CAB is congruent to FDE. That's talking about the same angle, and that's just a different way we can write that same congruency statement since we can name those angles the same way. Although that's repetitive because we already know that this angle is the same as this angle based on this statement. So absolutely right, but I want to talk about something that's going to be a little bit different. Manuel. All right, so ABC is congruent to DEF. Absolutely. What other congruency statement can we make about angles, Javier?
I have a question.
Oh, sorry, question.
Can any point be the vertex?
Can any point be the vertex? Yeah, absolutely. We can talk about these different angles. So if this is the angle we're talking about here, we're talking about the vertex is B. If this is the angle we're talking about, excuse me, we're talking about this angle, the vertex is A. We're talking about this angle, the vertex is B. If we're talking about this angle, the vertex is C. So all of these angles have different vertexes. There's one more statement we can make about the congruency of angles here in these two congruent shapes. We've talked about this angle, this angle, this angle, and this angle. One. Perfect. He says angle CAB is congruent to angle, so this was CAB. Wait, is that what you said? Oh, we've already got that one. We've already talked about this angle. We've got this angle and this angle taken care of. CAB is this angle. We've already talked about that guy. Marlon, what other congruency statement can we write about these angles? Say it one more time. So she has come down and come to our third angle, ACB, and has said that it is congruent to DFE. Now, that takes care of us talking about corresponding angles. We also said up here that corresponding sides of congruent shapes are congruent. So what do you think we can come over here in this segment category? What kind of congruency statements do you think we can make down here, Manuel? DE, line segment DE, so it's DE with the little line over the top of it, is congruent to AB. So this is congruent to this, absolutely. Could he have said that AB was congruent to DE? Does it matter which direction I write that congruency statement? No, it does not. What other congruency statements can we write about the line segments? Kendrick?
ED is congruent to BA.
Absolutely, ED is congruent to BA, but we've already talked about this line segment in this congruency statement, so we're going to not write another one about these two line segments. So what else could we write, Kendrick? Yep. EF is congruent to BC, so he's saying BC, EF, same deal. One more. Fernando. AC is congruent to EF. Don't have the numbers. Thank you. Good correction. Way to be on top of it. DF. DF. I don't have the exact numbers on it in front of me, but there were congruency questions where they gave you something like this. That was all the information they gave you. They told you that those two triangles were congruent. And then they said which of these statements is true. And they gave you a list of statements that looked like these statements down here. And I'm pretty certain that in one of them, actually I'm certain that in both of them, less than half of you got the answer correct. How easy is this? Super easy. So all you really had to do was draw the shapes, and it didn't matter how you drew them. You could have written all the congruency statements yourself and then said, which of these congruency statements that they are listing is on the list that I made? And it would have been as simple as that. So a lot of us struggled with that idea. One other idea that we do need to take away from this is that in case they give us the numbers, it says line segment BC is equal to 8. What other line segment is also equal to 8? Katie. What'd you say? AC? AC and BC are not the same. In fact, they're in the same shape. So we can't make any statements about anything within the same shape because it doesn't tell us any of the values. The only thing that we're being told here is that BC is equal to 8. But we do know something about BC based on the congruency statements that we wrote earlier. What other line segment should be also equal to 8, Raisa? EF. So if we look at this statement here, it tells us BC is congruent to EF. So that means if BC is 8, then EF must also be 8. The last thing, this is 100% review. This is a problem that we've actually even seen before. It says determine if the triangles are congruent, because we do have to be able to recognize if two shapes are congruent or not. Kip yes if these are congruent, Kip no if they are not. Kip yes if they are congruent, Kip no if they are not. Why are these not congruent, Michael? Yeah, they're not the same shapes. How can we prove that based on what we see here? Adriana. Yeah, it's slanted, so that tells us that this side is going to be different than this side. So they have different size sides, so these are not congruent. So they have different length sides. So two of their sides are the same. These two are the same, and the center piece is going to be the same for them, but these outside pieces are going to be different. Okay, questions about our work for today? Congruency is a